All right, let's talk about trigonometric identities. I know, that phrase can make some people's palms sweat. You might be having flashbacks to confusing proofs and way too many formulas, but what if I told you there's one simple secret, one master key that makes simplifying these things surprisingly easy? Take a look at this on your screen, secant theta times cotangent theta. Yeah, it looks like a bit of a jumble, right? It seems like you need a whole bunch of different rules rattling around in your head to solve it. But here's the cool part. A single, really elegant strategy can just cut right through all that noise and solve problems just like this one. So, what is this magic trick? What's this powerful technique that cuts through the confusion? Well, let's not wait any longer. Let's reveal the secret. Here it is. This is the big one. The single most effective strategy for simplifying pretty much any trigonometric expression is to rewrite every single part of it using just two functions, sine and cosine. Seriously, that's it. Think of sine and cosine as the foundational building blocks, the DNA of trigonometry. All the other functions, tangent, secant, all of them, are just different ways to combine these two. If you can master this one move, you're already most of the way to the solution. Okay, so to use this awesome strategy, you're going to need the right tools. So let's build your essential toolkit, the key identities that will let you convert everything into sine and cosine. First up, we've got the reciprocal identities, and these are super straightforward. Each of the other functions, cosecant, secant, and cotangent, is just the reciprocal, the flip of a primary one. Cosecant is just 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. Simple as that. Next in the toolkit are the quotient identities. These are a game changer because they put our master strategy directly into action. They show us exactly how to write tangent and cotangent using only sine and cosine. So tangent is just sine divided by cosine. And since cotangent is the flip of tangent, it's just the other way around, cosine divided by sine. These are your go-to conversion tools. All right, we've got the strategy, we've got the tools, theory's over. Now let's get our hands dirty and see how this actually works in practice. We'll start with a nice, clean example to warm up. Cosecant theta times sine theta. So, what's our master rule? Right, convert to sine and cosine. We see that cosecant, and using our reciprocal identity, we know that's just 1 over sine theta. Now we multiply that by sine theta. And what happens? The sine on the bottom cancels out the sine on the top, leaving us with a beautifully simple answer. And there it is. All that complexity just melts away and becomes the number one. Pretty neat, huh? Okay, let's level up just a little bit. How would we simplify sine theta divided by tangent theta? We are going to follow the exact same strategy. The sine theta on top, it's already a sine, so we leave it alone. But the tangent theta on the bottom, we can replace that using our quotient identity. It becomes sine over cosine. Now remember, from algebra, dividing by a fraction is the same thing as multiplying by its flip, by its reciprocal. So we take our sine theta and multiply it by cosine theta over sine theta. And look at that, the sine terms cancel out. And we're left with just cosine theta. See the pattern? The strategy just works. It's reliable. And now let's tackle the problem from the very beginning. Secant theta times cotangent theta. I know it looked a little intimidating before, but now we have the exact tools we need to solve it. It's not so scary anymore. Let's do it. We apply the master strategy to both functions. Secant, that becomes 1 over cosine. Cotangent, that becomes cosine over sine. When we multiply them, you can see the cosine on the top cancels out the cosine on the bottom. We're left with 1 over sine. And wait a second, we know what that is. From our toolkit, that's the reciprocal identity for cosecant. And there is our final answer. That complicated-looking expression simplifies all the way down to just cosecant theta. How satisfying is that? Now, this strategy is incredibly powerful, but it only works if you use your tools the right way. So let's quickly cover 2 of the most common traps that people fall into, just so you can sidestep them. Okay, first, it is so important to get the reciprocal pairs right. It's super easy to mix them up. Just remember that the co prefix kind of helps you swap pairs. Secant pairs with cosine, and cosecant pairs with sine. The second major pitfall is confusing the reciprocal with the inverse. That little -1 exponent you sometimes see means inverse sine or arc sine, which is totally different. That's about finding an angle. The reciprocal, 1 divided by sine, is cosecant. Getting these 2 details right is absolutely crucial. Okay, so this is all great for passing a math test, but you might be wondering, when am I ever actually going to use this? Why does simplifying these expressions even matter out there in the real world? Well, it matters a whole lot in fields like engineering and physics. For example, when an engineer is designing something like a fiber optic cable, the path light takes is described by really complex trigonometric formulas. By using these exact identities, that engineer can swap out parts of the formula, simplify it, and maybe reveal a more efficient design or make a tough calculation suddenly manageable. It really is all about turning a complex problem into a simple one. So, there you have it. You now have the master key. The next time you see a trigonometric expression that looks like a tangled mess, just remember that one secret: convert everything to sine and cosine. This fundamental skill is the launching pad for all the more complex and, honestly, fascinating proofs that come next. The only question is, what will you unlock with it?